Hello everyone, welcome to a new video. In this video, we'll discuss about JEE Advanced 2026 Paper 2 solution and particularly about section 1 in detail discussion we'll have. So let's start with section 1, question number 1. A metal wire of cross-sectional area 0.5 mm square and length 100 meter is connected across a battery of EMF 2 volt and internal resistance 1 ohm. The density, atomic mass and electrical conductivity of the metal are given. Assuming one conduction electron per atom of the metal, the drift velocity in millimeter per second of the electrons in the wire, you have to find out. Avogadro's number is given as well as the charge of one electron they are given. Let's start the solution. Question number 1. It is given that one wire is having some length, let's say 100 meter, that is given. Cross-sectional area that is given, A equal to 0.5 mm square, that is given. So right now we are trying to draw the circuit diagram. So it is connected with one battery of EMF 2 volt and it is also having some internal resistance, and what is the value of internal resistance, we'll just check. Internal resistance is 1 ohm. So we'll try to form our circuit like this, and this is the internal resistance I am drawing separately, so this is 1 ohm we'll draw. Okay. Density of the material of the wire is given and atomic mass is given, that is, let's assume m is the atomic mass, and it is given. Electrical conductivity is given, that is sigma is given. Rho is not given, that is the resistivity, but we know that conductivity is 1 by resistivity, so that thing we know, 1 by rho. Okay, now we have to find out the drift velocity of the electrons which are traveling here, which are there here, which are free electrons. They will be traveling in this direction, and we have to find out the drift velocity of the electrons, of the free electrons. So what is the formula we know? We know the formula, that is I equal to N E A Vd, where Vd is the drift velocity, I is the current in the circuit. The current, let's say current is I, that is flowing in the circuit. N is the number of free electrons per unit volume, E is the charge of one electron, A is the cross-sectional area of the wire, and Vd is the drift velocity. So from here, Vd is going to be I by N into E into A. N value is given to us, or we have to calculate that from the value given, density and atomic mass. You can calculate the value of N, that is okay. E is given to us, that is the charge of one electron is given to us, and cross-sectional area of the wire is also given to us. So Vd we have to find out, but for that we need to find out what is the value of the current I that is flowing in the circuit. What is the value of I? So from the circuit we can write that I is potential difference by internal resistance small r plus capital R, that is the this resistance, or this wire resistance is capital R. What is the value of capital R? So first we'll write 2 volt by small r is given as 1 ohm plus capital R. Capital R value is rho, or resistivity of the metal, into L by A. What is the value of rho? Rho value directly is not given, it is given in the form of conductivity, and conductivity value is 2 into 10 to the power 8 mho per meter, that is, this is equal to 2 into 10 to the power 8 mho per meter. So 1 by that is going to be our rho, that's it, nothing else, to the power 8. Now we'll just put the values. 2 by 1 plus rho value is 1 by 2 into 10 to the power 8 multiplied with the length of the wire is 100 meter by cross-sectional area is 0.5 mm square. We'll convert it to meter square, that is minus 6. So if we just simplify it, 2 into 0.5 is 1, so we'll write down, or we'll erase this. It is going to be 10 to the power 8, 10 to the power 6 is 1. So this entire denominator is being 1 plus 1, so 1 ampere is the current in the circuit. So now we know the current in the circuit I. So I is going to be 1 ampere. N we have to calculate from the data given. E value is the charge of one electron is given 1.6 into 10 to the power minus 19. Cross sectional area is given to us, that is 0.5 into 10 to the power minus 6 meter square into Vd. and Vd is becoming 1 by n into 1.6 into 10 to the power minus 19 into 0.5 into 10 to the power minus 6. Just n value, we have to find out number of electrons per unit volume, and we can find out the value of the net velocity. And it is given also that assuming one conduction electron per atom of the metal. I mean, if we find out the number of atoms which are present in this metal wire, we'll be just multiplying with 1 and we'll be able to find out the number of free electrons, and divided by volume, that is going to be your value of n. So now let's calculate the value of n here. So what is the volume of the entire metal wire? Volume is A multiplied with L. That is the volume. Mass multiplied with D, that is the mass. Divided by atomic mass is the number of moles, and number of moles is the number of moles multiplied with Avogadro's number, that is already given to us, 6 into 10 to the power 23 is going to be the number of atoms present in this wire, multiplied with 1 is the number of free electrons, so this is going to be your n. But per unit volume means you have to divide again by volume. Now this is our number of free electrons per unit volume, so AL will cancel out, it is just going to be D by M into 6 into 10 to the power 23, but D is the density. Density is given as 6.35 into 10 to the power 3. Atomic mass is given 63.5 gram per mole, but we have to convert it to kg. So if you want to convert it to kg, it is going to be 10 to the power minus 3 kg per mole multiplied with 16 to the power 3. If we simplify it, we'll be able to find out the number of free electrons per unit volume. So this is going to be 10 to the power 6, 29. This is 1 by 10, 6.35, okay. Multiplied with 6 into 10 to the power 29. So it is going to be 6 into 10 to the power 28 number of free electrons per unit volume. So per meter cube is also there. So we'll just put the value and our result will be there. 10 to the power 28 multiplied with 1.6 multiplied with 10 to the power minus 19 multiplied with 0.5 into 10 to the power minus 6. So 0.5 into 1.6 is 0.8, 0.8 into 6 is 4.8, and 10 power, if we calculate, it is 25, so it is becoming 10 to the power 3 meter per second. That is our drift velocity. Now this entire thing we can write it as millimeter per second, because we have to find out the drift velocity of electrons in millimeter per second. This is becoming, the answer is actually 1 by 4.8, but from the options we have to find out. See, 1 by 5 we know, 0.2, so 1 by 4.8 is a little bit higher compared to 0.2, so only option I am able to see, that is 0.208. 0.208 mm per second is going to be your answer. So option number C is the correct option. So next problem will now start is question number 2. Okay, it is given from modern physics part. A nuclear reactor starts producing a radioactive nuclide X from t equal to 0 at a constant rate of alpha per second. Each decay of X produces energy E naught, which is utilized to heat a liquid of mass m and specific heat S. Assuming no heat loss from the liquid and taking lambda as the decay constant of X, the rate of increase in the temperature of the liquid we have to find out. Let's draw the simple flow chart. What is happening? So one nuclide X is getting produced at alpha per second. A number of nuclides that are producing alpha per second. At the same time, it is also going to disintegrate due to radioactivity, and decay constant is given as lambda. And whatever energy is coming out per unit disintegration energy that is released, that is E naught, that is utilized to heat some liquid or I think water, or some liquid of mass m and specific heat S. We'll come to this point later point of time. Let's focus here. Let's see. at t equal to 0 it is given that this is getting produced or started to get produced at t equal to 0 time. After that slowly it will accumulate here, and as the number of nuclides are accumulating it will disintegrate into other nuclide, but this is the decay constant, right? Now at any point of time t, if we assume that the number of x nuclide is n number of x nuclide is present, then rate of accumulation of x is going to be dn dt or plus dn dt. That is the rate of accumulation of x dn dt. What is the rate of accumulation? Alpha. But at the same time some amount is going to get disintegrated into other nuclide with this constant, disintegrating constant. So lambda minus lambda into n, because we know from the radioactivity chapter that the rate of disintegration is lambda into n. So this is the rate of accumulation of this x nuclide. Now this is simple. dn, if we just separate the variable, lambda n is going to be dt. Now we just integrate. Now when t equal to 0, that time the number of nuclide was 0 because that time it has not yet started producing the nuclide x. At any point of time t, number of nuclide is, we have assumed n. Done. Now let's integrate this. This integration is going to be ln alpha minus lambda n divided by minus lambda, limit I'll put 0 to n. Here dt integration is t, limit is from 0 to t. Now this part I'll take here, minus lambda is going to be minus lambda t after putting the limits. The left hand side is going to be alpha minus lambda n minus ln of alpha only. So ln alpha minus lambda n by alpha is going to be minus lambda t. If we write in terms of exponential, it is going to be minus e to the power minus lambda t. So alpha minus lambda n is going to be alpha e to the power minus lambda t. So what is the value of n? N value is becoming 1 by lambda. Alpha, if you take common, 1 minus e to the power minus lambda t is going to be your number of nuclide at any point of time t. So number of nuclide as a function of t we have found out. Now let's focus on this reaction where the disintegration is happening. Now due to the disintegration only, the energy E naught is coming and that is going to heat the liquid. Now what is the rate of energy production or rate of energy release? Lambda into n. So number of or rate of disintegration is lambda into n. If we just multiply with lambda, we will get lambda into n is this one. That is the number of disintegration happening per second. So number of, or what is the energy released per second? This is the number of disintegration happening per second multiplied with E naught is going to be our energy released per second, and that is going to heat the liquid, and that is the entire heat is going to heat the liquid of mass m and specific heat s. This is the rate of temperature change multiplied with dt by dt. So what is the value of dt by d small t? E naught alpha 1 minus e to the power minus lambda t by m into s. That is going to be your answer. Rate of change of temperature of the liquid or rate of increase of the temperature in the liquid, that is matching with option number A. So your option number A is the correct answer. I hope you have understood. Now let's proceed to your question number 3. Section 1, question number 3 we'll discuss. It is given from ray optics. I just write down the number, question number 3. A beam of polychromatic light passes through a thin prism of prism angle 6 degree. The refractive index of the material of the prism varies with wavelength lambda as n as a function of lambda is given as alpha lambda plus beta by lambda square, where the value of alpha is given, beta is also given. Lambda mean is the wavelength at which the angle of minimum deviation is smallest. Minimum deviation is also smallest, so you have to remember. Then the correct value of dm, or the minimum deviation at lambda mean, that you have to find out. Let's write down all the data. Now you know that deviation or delta for a thin prism, because the prism, this angle is given as 6 degree, that is very thin prism by the way, and for a thin prism we know that your deviation is mu minus 1 into a, that you already know it. But deviation you have to make it minimum, and mu here is a function of lambda, so we will not write mu will write as function of lambda directly, minus 1 a. So with wavelength, basically that means with wavelength the refractive index of the prism is varying. It has different sensitivity to different wavelength. Delta, which is the deviation, this is also a function of lambda. Now for a particular value of lambda we will get minimum of delta. Delta is the deviation. Now delta I am getting as a function of lambda. So let's put the value. Alpha lambda plus beta by lambda square minus 1 into a, that is going to be our delta. So we'll get a minimum value for a particular value of lambda. So what is the minimum? Whenever this will become 0, that is the minimum condition or maximum condition, but in this case we will get minimum for sure, that is why it is given. So alpha, this differentiation is 2 beta by lambda cube, this is 0 by the way, multiplied with a is going to be 0, that is why we'll just remove a here. Now lambda cube I am getting 2 beta by alpha. Now the values of beta and alpha will put from the question. Beta value is 0.096 and alpha is 3. Beta is 0.096 and alpha value is 3, that is equal to lambda cube 3.032.064, that is equal to lambda cube. So lambda is becoming 0.4 micrometer. So for this value of lambda we'll get the minimum deviation. Now it is simple, we'll just put the value here, we'll get the value of lambda. So lambda mean minimum deviation is going to be, alpha value is 3 multiplied with 0.4 plus beta value is 0.096 by this square is 0.16 minus 1 multiplied with 6 degree. So this is, first term is becoming 1.2, second term is becoming 9.6, 0.6 minus 1, 6 degree, this is becoming 1.8. So 0.8 multiplied with 6 degree, that is 4.8 degree is going to be your minimum deviation for the prism. 4.8 degree is option number B. So option B is the correct option. Thank you. I hope you have understood. Now let's start solving question number 4, which is by far the toughest problem of JEE Advanced 2026. Let's start the problem. A particle of mass m and angular momentum L is moving in a circular orbit of radius r0 under the influence of an attractive force F as a function of r is given as minus k by r square r cap. Keeping its angular momentum unchanged, the particle is displaced radially by a small distance delta r, which is very less than r0, due to which its radial distance varies periodically. The corresponding time period you have to find out. This is a problem from SHM. Now let's try to understand the theory part of the problem, then we'll start solving the problem. What is happening here? Now there is one particle, let's say of mass m, which is rotating in a circular orbit of radius r0, is rotating. So if we assume cylindrical coordinates, this is the radial direction, this is the tangential direction, theta cap. Now the mass which is moving in a circular orbit of radius r0 it is in radial equilibrium, or in radial direction the net force is balanced. How the net force is balanced? Let's say it is rotating with omega angular velocity. Its outward force is going to be m omega square r naught. At the same time, it is under the influence of one central force that is acting towards the center, and that force value is k by r square. That is the value, and the that is the magnitude, and the direction is towards the center. Now they both are balanced. That means it is in radial equilibrium. Radial equilibrium. I'm writing EQU. That's it. Okay. So in r cap direction, it is in equilibrium. Now whenever this mass is slightly displaced in this direction, delta r. By the way, its angular momentum is assumed to be constant, and the angular momentum small l, is m into v into r. V is the tangential velocity. V, if we put omega into r, we'll write m omega r square. Okay. Now at the equilibrium position, the radial equilibrium position, it is r naught square. Now whenever this mass is displaced by small amount delta r in this direction, it is assumed that angular momentum is conserved. That means angular momentum is not changed. So whenever it is displaced by delta r distance towards outward, in the outward radial direction, this force is going to decrease. This force is going to increase or decrease depending upon this one, so that it is in equilibrium. Because whenever you displace in this positive r cap direction, omega is going to reduce because your angular momentum is constant. Whenever the distance from the center is going to increase, your omega will adjust itself so that the angular momentum remains constant. So angular momentum will be constant, and the product is going to be m omega square into r at that time. And in the r cap direction, there will be net force m d2r by dt2. There is going to be a net force towards radial direction, and that force will be restoring force in nature, because that is how it is going to come back again to the same position. But it will not be able to stop here because it has already acquired some velocity in the r cap direction. So it will oscillate, keeping the perimeter as the mean position. So now entire perimeter is becoming your mean position. So it is going, because it is already having some rotational velocity or angular velocity, so it will rotate with respect to the perimeter. It will rotate with respect to the center, keeping the perimeter as the mean position. It will oscillate. The mass will rotate with respect to the center, but keeping the perimeter as your mean position, the mass will oscillate in the radial direction. Now this is going to be the trajectory or the oscillation pattern. Now entire perimeter is becoming your mean position. So please write down mean position is perimeter. Now whatever we know from the equilibrium position, we'll write down. So at equilibrium or the radial equilibrium position, whenever small perturbation is not given to the mass, that time L is equal to m omega r naught square. At the same time, outward force is going to balance the inward force. So we'll write m omega square r naught is going to be k by r naught square. These are two equations. Now from these two equations, if I omit omega, I will be able to find out one relation between L, R naught, K. Let's find out that, and we'll try to keep it here only. So L square by m square R naught to the power 4, that is going to be omega square, and that value we can write as K by m R naught cube. So L square by m R naught cube, I will write down as K by R naught square. That is one relation. This is another relation. This is another relation. Now let's try to formulate our SHM equation. Now at any random position, we'll just consider let's say the random position is r. This is the mean position, and random position is r. We'll consider r. So at r distance, whenever the particle is crossing the r distance from here to here like this, then central force towards center, your force is going to be k by r square minus outwards centrifugal force is, at that time your omega is going to reduce, as I have told. So omega bracket r square will write, then r is going to be your inward force, restoring force in nature, minus m d2r by dt2, or minus m into a r suffix we can write. Now this r I have given small perturbation from the mean position. So from mean position, r naught plus delta r will write as small r. So k, I'll just put the values, k by r naught plus delta r whole square minus m. This omega is going to change, but what is going to be fixed? Your angular momentum is going to be fixed. So if I put the value of L, so omega value is going to be L by, at that time your angular momentum is going to be m omega bracket r square. So omega r is going to be L by m r square, and r square I'll write r naught plus delta r square. So I'll just put the values. Omega square bracket r is going to be, the square of that term is m square by r naught plus delta r to the power 4. Again here small r is there, but smaller value is r naught plus delta r. That is going to be equal to the right hand side. I'm not writing as of now, I'm trying to simplify this part as of now. Now from here, denominator, if I take r naught common, then it is becoming r naught square. This entire part is becoming 1 plus delta r by r naught square. Again this term, if I simplify, it is becoming is r naught, if I take common, so r naught cube is becoming 1 plus delta r by r naught cube. Then k by r naught square, this one I will put in the numerator, and the value will become minus, sorry, r naught. This is just binomial. This one, if I take it in the numerator, it will become 1 minus 3 delta r by r naught. This one again, if I simplify, k by r naught square minus 2k by r naught cube multiplied with delta r minus L by m r naught cube plus 3L by m r naught to the power 4 delta r. Entire term I am trying to simplify. Now see, k by r naught square is equal to L square, sorry, this is going to become L square, sorry, L square by m r cube. So this is going to get cancelled. This is also going to be L square, by the way. These are going to get cancelled out. And this one, if I rewrite here again, only the left hand side I am writing 2k delta r, if I take common, 2k by r naught cube minus 3L by m r naught to the power 4 L square, sorry, that is going to be our left hand side. Now L square by m square r naught to the power 4 is k by m r cube. I have already done it here. So delta r, if I multiply one m r naught to the power cube minus 3L square m square r naught square. See, this one and this term, these two terms are equal terms, these two terms. So if I, instead of L square by m square r naught to the power 4, if I put k, it is going to be m delta r 2k by m r naught cube minus 3k by m r naught cube. So it is becoming minus m delta r k by m r naught cube. So m I will again omit. That's it. So our equation is becoming, this our SHM equation is becoming m d2r by dt2 is equal to delta r into k by r naught cube. So minus we'll just ignore, just take the mod values because this is is very trivial. So d2r by dt2 is becoming k by m r naught cube delta r, rate of change of the distance from the mean position. So instead of r we can also write delta r because that is going to be same. Anyway, so this is going to be our omega square. Omega square means the angular frequency square will make it big omega, k by m r naught cube. Now we have to simplify it in terms of our answer given. Answer is given in terms of kl. There is no indication of r naught cube because that we have assumed already. Let's try to put the value of r naught. So we already found out, this part I'll erase then. We have already found out the value of omega square, that is the angular frequency, that is k by m r naught cube. But I have to find out the answer in terms of k and l. So let's try to put the value of r naught from here. As simple as that. Then now see, from this equation I can find out the value of r naught. R naught is going to be, cube square will cancel out, it is going to be l square by mk. If I am not wrong, l square by mk, yes, that then I can put the value here. L square by mk is this is becoming m square k to the power 4 by l to the power 6, that is becoming our omega square, the angular frequency square. So angular frequency I can write, that is m k square by l cube. So time period is going to be 2 pi by omega is 2 pi l cube by m k square. That is going to be our answer, and our answer is matching with option number A. So option number A is the correct option. Now please see that this question had many calculations, many small calculations are there. If you mistake in any one step, then your answer will not come properly. Let's assume that this step you have made some mistake, plus minus mistake you have done, it is becoming plus. Then the answer will get divided by 5. The answer will get wrong, like completely wrong answer will get. If you have done some mistake here, you will get totally wrong answer. So this is the right answer, by the way. Thank you so much.